Welcome to Tech Talks Education. Let's look at the effect of inhibitors. The effect of inhibitors on enzyme activity. On enzyme activity. We already know what an enzyme is in our preceding videos. Let's look at the definition of an inhibitor. We would say that this is a chemical substance that affects the activity of an enzyme. Instead of affecting, you can even go further and say it even does reduce the activity of an enzyme. So what it does, inhibitors carry out inhibition. And inhibition from the language of biology, which is Greek and Latin, it would mean to stop. But you are going to understand it further and say, inhibitors may not necessarily stop the chemical reaction, but can reduce, but can affect it, and in most cases negatively. So we can first look at the effect of presence of an inhibitor. When an inhibitor is present to an enzymatic reaction, what happens? Most inhibitors compete with the enzyme do not compete with the enzyme, but rather compete with the substrate for the same enzyme, such that catalysis of the substrate is stopped. Can borrow that word of stopping, because inhibition means stopping. So this is the biggest effect. Inhibitors compete with the substrates for the same enzyme. Meaning the enzyme that is made to, let's say, to digest starch, will no longer be digesting starch, will now be catalyzing another reaction. Let's go ahead and see the types of inhibitors. We shall largely take 3 types of inhibitors. The first one we term it as competitive inhibitors. Then the next one, we can call it the non-competitive inhibitors. And the other one, we can call it allosteric inhibitors. Allosteric inhibitors. Let's expand one at a go. What are competitive inhibitors? What are competitive inhibitors? When I said that inhibitors compete with the substrates for the same enzyme, but now we can continue and say, if it is a competitive inhibitor, what does it compete for? These substances compete for the same active site, on the enzyme with the substrate. Meaning, if this is the enzyme and that is the substrate which is supposed to be acted upon, this is our enzyme represented by E, and that's our substrate. If there is an inhibitor, the inhibitor also has the same configuration like the substrate, if that is an inhibitor. In that, all can bind to the same active site in the same way. So they compete for the same active site in the same way. In our subsequent videos, we shall now know what an active site means and other sites on an enzyme. Then non-competitive inhibitors. For this, they do not compete directly with the enzyme, with the substrate, but rather they can bind to the enzyme even when the substrate is already bound there. So we can define them and say these are substances that can bind to the enzyme whether the substrate is already bound or not. That's why they are called non-competitive. They won't compete for the same active site, but they can go further and compete for the same enzyme, but at different sites. That would be a non-competitive inhibitor. So meaning this one is more dangerous. It does not care whether a desired substrate is already bound to the enzyme or that substrate is away. We shall get some examples of non-competitive inhibitors, which are the leading poisons in our day-to-day life. Let's take the third one, allosteric inhibitors. Allosteric inhibitors. These inhibitors These are substances that bind elsewhere on the enzyme if the this is another word here, they bind elsewhere on the enzyme rather than the active site. That other site of the enzyme is what now we shall refer to as allosteric site. So those are the main three types of inhibitors. Now subsequent, now let's come and look at the structure of the enzyme, where the allosteric site is found and where the active site is located.